Okay, today we're going to be doing learning how to calculate solubility. And as we remember from the last lesson, solubility is the maximum amount of solute that can dissolve in a given amount of solvent. In other words, an equilibrium is formed with the solid of a solute and the dissolved solutes. Anyways, so right here we have two questions, and we see that it's aluminum fluoride has a solubility of 5.59 grams per liter at 20 degrees Celsius. Now express this in moles per liter. So we're just going to use stoichiometry to change 5.59 grams per liter into moles per liter, or in other words, molarity. So what we should do is, well, our solubility is going to be equal to 5.59 grams per 1 liter. Now, I'm going to multiply this by the molar mass of aluminum fluoride, which happens to be 1 mole of aluminum fluoride has 84.0 grams in 1 mole. And when I multiply this together, what I'm going to get is my grams are going to cancel out, and I'm going to have moles over liters, or in other words, molarity. So what we're going to see is we're going to have 5.59 divided by 84, and we get 6.65 times 10 to the minus 2 moles per liter. And so all we did was use stoichiometry to change this grams per liter into moles per liter. Now here's another problem, a question, and we have lead chloride, which this should be subscript, has a solubility of 0.99 grams per 100 mils, and it says calculate the molar solubility. Now molar solubility is just another way of saying moles per liter. So it's just a different way of saying moles per liter, or in other words, molarity. Okay, or maximum molarity. So again, we're going to take our solubility, which is 0.99 grams over well, I'm going to change this 100 milliliters into liters, and that's going to be 0.1000 liters. So I just took 100 milliliters and changed it right into liters, and I'm going to multiply that by our molar mass. And our molar mass is, well, 1 mole is equal to 278.2 grams. Okay, so lead chloride, or lead 2 chloride, has a molar mass of 278.2 grams. And again, same thing, 0.99 grams. Our grams is going to cancel out, and we're left with a unit of moles per liter, or in other words, molar solubility. And what we get is, well, 2 sig figs divided by 4 sig figs, and then again divided by another 1, 2, 3, 4 sig figs. We get an answer that is 2 sig figs. So that's going to be 3.6 times 10 to the minus 2 molarity. Okay. Now here's another question right here, and what I'd like you to do is try putting the video on pause and see if you can answer this question. What we see here is we have manganese chloride, and this has a molar solubility of 5.75 moles per liter, and if we had 125 milliliters of saturated manganese 2 chloride and it is evaporated, so all the water is removed to dryness, what mass of manganese chloride will be left over? So try putting this video on pause and see if you can answer this question. Okay, now hopefully you did that, and what you should find is that what you're looking for is the mass of manganese chloride, and so that's what you want. So you're going to start off with your solubility, which is 5.75 moles per liter, per 1 liter. Okay, and then you're going to take this and you're going to times it by the amount of liters you have, so your liters will cancel. So you're going to multiply this by the amount of liters you have, which happens to be 0.125 liters from right up here. Okay, now what unit you have is moles of manganese 2 chloride. But we want to know what the mass is. So again, we're going to multiply this by, well, our molar mass of manganese 2 chloride. And I've calculated the molar mass already, which happens to be 128.9. So 128.9 grams is the molar mass of manganese 2 chloride. And if we take 5.75, multiply it by this number, and multiply it again by this number, we should get approximately 90.5 grams of MnCl2. And same thing, 3 sig figs, 3 sig figs, 4 sig figs. Our final answer is 3 sig figs.